the electric potential inside a charged spherical conductor of radius r is given by, so V inside equals to K Q divided by R. You know, it's a conducting object. And inside the conducting object, we don't have Q, and we don't have a field. E equals to O. The total charge of this object equals to Q. Okay? And the potential outside is given by outside V equals to K Q divided by R. So if R is less than capital R, we have V equals to KQ divided by small capital R. Okay, and if R is greater than the capital one, you get V equals to KQ divided by R at this point. You have to use this relation to derive the electric field inside and outside the charge distribution. So what does it mean? I have to use this relation to find that E inside the conducting object equals to O. And E outside, outside here, E equals to K Q divided by R square. So I have to find E equals to O and E equals to KQ divided by R square by using this relation. Okay, let's start by the first one. R is less than capital R inside the conducting object. E at this position equals to minus D divided by dr, and V equals to K Q divided by the distance. You know, K is constant, Q is constant, and R is constant. So the derivative of a constant value equals to 0. So inside the conducting object, we don't have a field. Let's take outside the conducting object. If R is greater than or equal R, E R equals to minus D dr K Q divided by R. Okay, we can put this one here, so we get minus D divided by dr. Anyway, here, K is constant, you have minus, and the Q is constant. So here we have D divided by dr of R minus 1. Okay, the derivative of A equals to, if you have here 1, equals to 1 A 1 minus 1. Okay, so equals to 1 because A 0 equals to 1. Anyway, here we get minus k q times minus 1 r minus 1 plus 1. Okay? No, minus 1. Excuse me. Minus 1 minus 1. So we have minus k q minus and minus plus r minus 1 minus 2. It means r square. So E r equals to k q divided by r square. Like this, you have to know, in general, you have this relation between the electric potential and the distance. You know, delta V equals to minus E dr. So delta V, or between 1 and 2, equals to V2 minus V1 equals to minus E dot dr of ds. Okay, between R1 and R2. This is a very important relation to calculate the difference, the change of electric potential from the electric field. We calculated in the last video.